Hello, welcome to this third lesson in physics. This one is titled Is Friction Useful? And there's no actual practical in this lesson, so we're really just trying to consolidate using key vocabulary and some key ideas that we've covered so far by testing our comprehension on how we can answer simple questions about forces and friction. So please put the date in today, just show you where you are. So that's the first two lessons we've done about forces. Friction investigation with the shoe and the carpet, and here we are. So let's get started. So nope, not there, here. So I'd like you to pause the video in a second, and I'd like you to look at those situations, see if you can identify where there might be friction, and then tell me whether it's useful or not. So pause the video now. Okay, so you've had a little think about these. Now in class, clearly what I'd like to do is go round and discuss these, but clearly you should have your own ideas now. So I probably won't get every single bit of friction in these diagrams, but let's start with A. I think fundamentally what we're looking at is this part here. That lady or man, whatever, is sitting on the grass, and there is friction between their bum and the ground and their feet and the ground. And if there wasn't, fundamentally they wouldn't be able to sit on a inclined bank like that. And the friction fundamentally, I would say, is going in that direction up the hill. Okay. Let's look at the fireman sliding down the pole. So in that sense, I would say it's useful. It's useful in B. So now let's look at the fireman. Now, hopefully, fundamentally, again, I think fundamentally you should really have spotted this area. It's really down the pole. And he's got friction between his hands and the pole and between his legs and the pole. Now, you can interpret this any ways you want, whether it's useful or not. I mean, some people say if the pole didn't have any friction, he'd go down too fast. And if the pole was too rusty, it would stop him moving down the pole, and the idea is for him to move down the pole fast. Fundamentally, I think, again, the friction, you would generally agree, is upwards. So the force of friction is upwards. I think we'll just leave it to our own judgment whether you want to call that useful or not useful. Clearly, it's useful if you don't want to go down too fast, but it's not useful if it's stopping and getting down to the base. Okay, C, what are we looking at here? Well, I think there's a few things going on in this one, so it's a little bit more tricky. Firstly, there's certainly friction going on underneath the tyres, and I'm talking here about the friction between the road and the tyre. The friction between the road and the tyre enables the wheels to turn, and instead of the car just staying still and the wheels spinning, the car is actually propelled forward. But there is another type of friction going on, and it looks like it's going on the brakes here. Inside, there is a mechanism for braking, and that braking normally has some sort of brake pads on there. The brake pads push onto the wheel to stop the wheels turning around as fast, and that friction as well, a slightly different type of friction, that's to actually slow the car down. So you've got friction that enables the car to move along and friction that slows the car down. That friction would probably be more sort of inside the wheel mechanism somewhere. So I would suggest both of those are very useful types of friction for a car. Okay, what have we got here? I think the key idea that people want to realise, I would suggest, is that wheels that turn have reduced the friction between the ground. So now the wheels are just rolling over the ground, they're not dragging over the ground, so they generally reduce friction. However, I'll come back to the same point as the car. Inside the bearings, perhaps in here, let's try and make these nice and small. Inside the bearings of each one of those little wheelie points, there will be some little bearings, some little round balls that have to get pushed on and have to rotate around, and they will be wherever they're in contact. Clearly, there is going to be some friction. Next one. Okay, we have a man standing on a ladder. Well, there's three significant points of friction, I would suggest here. That ladder would slip, firstly, if he was standing on that ladder. If there was not friction, that friction here acts in that direction. Oh, I need to change to a pen. There you go. There's friction acting in that direction because the ladder wants to slide out. On this part of the ladder wants to slide down, so there's friction acting in here. So there's two bits of friction between the ladder and the wall and the ladder and the surface. Also, there's friction going on in here. When this is rotating, yeah, when that rotates, clearly there's going to be friction between the drill. So I would suggest, certainly, the friction that keeps the ladder upright is useful. I suppose the friction in the drill is useful, really, because it's causing the brick to be worn away and pulling it out. So, you know, there's no necessarily correct, right or wrong answer in all of these. It's just really the observation that friction occurs in so many situations. So, I'm going to show you this now. Now I've got some keywords at the bottom, so to help you if you really need them. If you want to just use there's no keywords in the book, so if you want to look in your book and have a go at doing that now. So have a pause and see if you can complete this, and then I will come back and go through the answers. Okay, hopefully you've had a good attempt at that now. So let me try and go through the answers. Friction is a force caused by two moving objects over each other. Caused by two moving, oh, I think I'm missing the word there, objects over each other. Rough surfaces produce more friction than smooth surfaces. Friction can be helpful because it stops us, I think you have slipping or sliding there, slipping or any sliding when we walk. Also, brakes that slow down cars or bicycles would not work without friction. Friction is not always useful. It can cause sound, and I'm going to use that word again because I've got one. Sound and heat, or heat and sound, like in the drill, that would be cause a lot of heat and sound. And it can also wear away things that rub against each other. So not always useful. Oil can reduce the amount of friction. So if you have on the cyclist or the person on the roller skate, if you put oil in the bearings, that can also help reduce friction. Oil also stops the surfaces touching each other. Liquids that reduce friction are called lubricants. Okay, make sure you've got those complete, and we'll go on to the next question. Okay, so this is a question really about a girl. I think at the start she's just preparing her bike, ready to get it in good working order, and she's cycling up a hill. She's coming down a hill, and she's coming down a hill into water. So could you have a read of those questions and have a go at answering, and pause the video now, and then I will come to and I will just discuss what the answers to those questions are. Okay, right, here we are. You really shouldn't be listening to this unless you've had a good go at answering all these questions. Now, clearly, your answers might be slightly different from the ones I do. We're looking for, you've got to be sensible here, because if you're not in lesson, but you can still have an idea of what your good answers are. Anything that you really want to query with me, you can query when we're back in school. But, you know, you really just want to think, do you fundamentally understand the ideas that are going on? Sometimes I hear really good answers in class that I have not suggested. And so, you know, maybe you've got some of those. So, but you should really be on the same track in most of these questions if you're making good progress. So, which parts of the bike should the girl oil, and explain why? Well, hopefully most of you would know the best parts of the bikes to oil are the bits where they have the moving parts. So I suppose that because they're the parts that rub against each other, and if they're rubbing, they're moving, and if they're moving against each other, then they're going to cause friction, and you've got to supply force and energy to overcome that. So the points I would certainly be looking at for are certainly the chain, and perhaps even those bearings of where the chain and the oil. So anywhere where there's moving parts, so where the bearings, where the center of the front wheel, where it connects on, and the chains and the oil, and I suppose the gears as well. The gears need to move and slide around as well. So, but probably not as significant. Okay, you should never put oil on the wheel rim. So that's around the edge here. That's around the edge. Particularly that point there. Explain why not. Well, generally, unless you've got one of those nice fancy bikes now, what are they called? Well, the central disc and disc brakes, which is another point you should never put the oil on. But the old-fashioned brakes, where they're on at the top on the wheel rim, will the friction there is useful because when you apply the brakes, you want to stop the bike from moving because it might be trying to avoid an accident or just slow down. So if you put oil on the brakes, they could be your disc brakes or your just the brake block brakes. That would be a no-no. That would be a very bad idea because it would make the brakes less effective. In that sense, friction is your friend. The girl going uphill is working very hard. What forces is she pushing against? Well, the main force that she's pushing against as she goes uphill is gravity. When you're going uphill, even if you're going up an incline, you are fighting against gravity. I mean, good little tip, if you're going up a hill and you zigzag from side to side, you might be travelling at the same speed, but you could actually fight less against gravity. So if you do large zigzags when you're going up a hill, it will feel a bit easier. What forces is she pushing against? So you've got one is gravity, the main one. I suppose the other one would just be sometimes we just call it resistive force, all those little bits of friction that she's fighting against, because all the moving parts of the bike will have a small amount of friction. With a well-maintained bike, that should be less. But every single part of the bike that is moving or rubbing against somewhere else will produce a little bit of resistance. And I would just put all of those together and call it resistive force. Okay. What are two forces slowing bike C down? What are the two forces slowing bike C down? So bike C is when she's coming down the hill. Okay. First of all, again, I would say a quite significant one. She's coming downhill and you can see, look at her hair. Her hair has been blown back. And fundamentally, there's loads of air particles that she's pushing out of the way. It's sort of like an air friction, but we don't normally say the word air friction. We call it air resistance. So that would be a good word for here. So you can see as she goes down the hill really fast. Again, I would still say there's also any part, even if she's not cycling, in the wheels, there will be contact forces between the wheels, will be rubbing against the bearings inside there. And so any part of the bike that is moving compared to another part of the bike, there will be resistive force. So I think you could just call that the main one. I think the main one there would be air resistance though. And in D, what's going on? In D, lady comes down, she smashes into the water. I'm pretty sure what we'd see would happen there, she would slow down. Okay, so really what will happen to bike D is it goes to the puddle, it will slow down. Why will this happen? Well, again, I suppose you would call, instead of air resistance, we've got now water resistance or drag, sometimes it's called. And because water particles are so much more dense and closer together than air particles, then we will get more resistance, we'll get more particles in contact with the bike that the bike has to put out of the way. In effect, it's sort of like a big increase in friction. Okay, it's gone from air friction into water friction, or as we would normally say, air resistance into water resistance. Okay, same format here. Have a little go at doing these. And then I will go through the answers. Anita's mum, and Anita got her mum's wedding ring stuck on her finger. Her mum added a little washing up liquid to the ring before trying to pull it off. How can adding washing up liquid help remove the ring? Well, I think there's there's one fundamental point to say here. One, it reduces friction. It reduces friction. You could have said two things, but the second one is also involved in the next question. The washing up liquid acted as a lubricant. That's the key word, one of the key words from today. The washing up liquid acted as a lubricant. That means it's a liquid that gets between the gaps of two rubbing surfaces and reduces the friction because the surfaces aren't in contact anymore. Give two other examples that could be used instead of washing up liquid. Well, I can give you two quite common ones. Oil might be a good one. Maybe soap even would be a good lubricant in that situation. WD-40 is a very common lubricant that is used in household situations. I don't think you probably want to put it on your fingers for this one, but any sort of oil or soap or any other sensible suggestion might work in there. Angela enjoys going fast on her skis. Before going on the slope, she always rubs wax on the bottom of her skis. How does the wax help Angela ski faster? Well, quite simply, what does the ski? It's in effect a lubricant between the skis and the surface. So even though there's not a lot of friction between skis and the ice or the snow, if you add wax, that reduces it even further. So how does it help ski faster? It reduces the friction. What two forces slow Angela down as she travels down the ski slope? I would suggest there's two main ones here. One, it's the friction between the skis and the surface, the one that she was trying to reduce in the last question. And two, I suppose, same hair flowing backwards here again. There we go. That must mean she's traveling down fast. She's pushing air particles out of the way. So that other word that we use for air friction, we don't use the term air friction normally. We normally say air resistance. Now I will come on to this last task here. We often don't get into this in lesson. This is just like a little extension task. So, if you want to have a go through these, I've written at the sides, so TR, PT, TR for true, PT for partly true, and FA for false. I am just going to give a little overview of what I think might be good answers for these. There's no definitive right answer. You might interpret the question slightly differently, but if you want to, we can have a go at doing it. Put down your best ideas, scribble some notes down, and then listen to what I say as well. If you disagree with me, that's fine. This is just my best views on these. I don't think there's any particular exact correct or exact wrong answer. Friction always slows things down. I think we're going for true on that one. I think that's true. Cars need friction to stop. Pretty much, yeah. I can't see how a car could stop without applying the brakes. And even if you didn't apply the brakes, it would just come to a gentle stop, but that would still be caused by friction. Friction is useful to gymnasts. I don't know exactly where they're going with this question here, but I suppose, if you're doing any sort of movement or jumping off something, you need friction. If you're on the horse or you're holding onto the rings, you can't hold onto the rings if there's no friction there. You can't get a grip on anything. Friction is useful to ships. Not sure. I might have to come back to that one at the end. I'm not sure exactly where they want to go with that one. You could not pick up a cup of tea without friction. Yes, I suppose. Partly true. I suppose you could hook your fingers around it. Depends exactly how, and then just lift it up. That would be more of a contact force. If you want to hold it around the side of the cup, then that would clearly need friction, more like a glass. If you were holding like a glass, you wouldn't necessarily need friction, that you might not be able to move it into position quite well. Snow increases the friction between your shoes and the ground. Well, I would go partly true. Certainly ice doesn't. Snow, I think snow could have, if it was deep, soft snow, then really you might not find it, they might increase the friction. But if you were on ice, that would certainly reduce the friction. Okay. Pencils do not need friction to write. That is false. I'm pretty sure that's false. If you rubbed the pencil, it'd be like a match. If you think a match, trying to light a match, there was no friction, it wouldn't light. What you're actually doing when you're doing a pencil is you're rubbing away small amounts of graphite onto the piece of paper, and if there was no friction, the graphite would not write. Cars need friction to keep moving. Oh, do they need friction to keep moving? I would suggest that is false. If there was no friction at all and a car was moving, it would just keep on skidding across. Okay, the wheels might not be turning at the same speed as the road beneath them, but I think the car would keep moving. So if you went on ice and then you hit the brakes, and the car would just keep on moving in a perfect icy conditions. You could not walk without friction. I think I'd have to say true with that one, because you need to get grip with your shoes. Remember our experiment? Matches light because of friction. I would suggest that is also true. If you can't have any friction between that sandpaper and the match. Shoelaces stay tied because of friction. Yeah, I think if you have shoelaces that come undone, fundamentally it's that friction that holds the knots together. We have done that, haven't we, in that experiment in lesson 1. So I would suggest that's fundamentally true. You could drink from a glass of water without friction. Well, if you left it on the table and then just slurped it, I suppose you could. You would actually find it hard to pick up the outside of a glass and actually lift it without any friction at all. Friction is useful in playgrounds. Well, that certainly is useful if you're spinning around on a I can't remember what the word, a roundabout, and you get flung outwards. It feels like you're being flung out. If you can't hold on to something, if you can't hold on to the strings of a slide, of a swing, then you will be thrown off. I suppose on slides, friction is not as useful, I could imagine. So if you go down a slide, but that doesn't mean it's not useful in other situations. So certainly on a slide it's not useful. You really want less friction. There is no friction when you are roller skating. Well, that's clearly false. Roller skates reduce friction. That's the whole idea of roller skates, that you reduce, because the balls just roll over the water as opposed to the surfaces without rubbing. But the friction will be replaced by friction in the bearings. Now that is a lot less than otherwise you would experience, which is why you can roll quite quickly, but there's clearly going to be friction. Let's go back to friction is useful to ships. Well, I'm going to go with a false, because I can't think of any particular purpose of why a boat needs friction. Useful to ships, unless they're talking really asking us to think about a boat or a ship pushing through the water, and you can think of the water as being a causing friction to the movement of the boat, in which case yes, it is. It's false. Okay, if you've done all those tasks, then well done. You've probably done more tasks than we managed to do in the class, because the class only lasts 45 minutes. So nice, thoughtful answers. Make sure you can also jot down any other comments that you've come across. Please feel free to go and look at the golden checklist at the front, just to check that you're up to date and you're self-assessing your work of where you are. Okay, thank you very much. Bye-bye.